Welcome to the SAP HANA Academy. My name's Bob, and in this series of videos we're going to be looking at some of the new features in SAP HANA SPS 10. In this series of videos we're going to be looking at some of the new features within text mining. So in this video we're going to be looking at a new feature in SAP HANA SPS 10 related to text mining. Now, text mining wasn't new in SPS 10, it actually existed in SPS 9. The difference was that in SPS 9 you had to access your text mining repositories using XS API. The great thing about SPS 10 is, like text analysis, you can now access your text mining repositories using basic SQL. This is really easy and powerful for developers to use. So in the previous couple of videos we looked at initially a chalkboard on the overall concepts of text mining, and then in the previous video we looked at the steps needed to create the text mining repository of information using a full text index. What we're going to do in this video is look at the text mining SQL API and look at running some SQL statements to extract information from our text mining repositories. We're only going to spend a few minutes on this because this is kind of like an overview, and of course in future videos we're going to go through more in-depth samples. So to give you some quick background, we've got a table that consists of 4 columns, an ID, a file name, and then we've got content in English, and this is our content, our source content. So these are what we call our documents. So this actually is it could be thousands of words stored in my example in blob format. I've got 12 documents. What I did in the previous video is I built a text analysis index, which again is a prerequisite in order to do text mining. So I covered how to build these indexes, and I showed you if you want to build your own custom text mining configurations, how to do that, although we're going to investigate text mining configurations in a later video. Now, how do we extract the data? Well, the way it works, the SAP HANA SQL API application, is that we use a series of text mining functions. You access these text mining functions with SQL, and the return results of each function is displayed either in SQL, which is new in SPS 10, or of course in the previous release SPS 9 you could do this via the XS API. So there are different types of text mining functions. We've already kind of looked at one which was called initialization. That's how you build your text mining repository. You do that with a full text index and you have to merge delta the data. There's 3 main ways you can extract data. One of them is term document functions, another is categorization and statistical analysis. And we're going to look at categorization and statistical analysis briefly here, but more in depth later on. We're going to focus more here on term document functions. There are 5 types. We're not going to go all through 5 types, but I'm going to give you some nice examples of how it works. So to do this, of course, I'm going to launch a SQL console. So this is what a sample SQL statement looks like. So essentially, you access your text mining repository through these functions. This function here is called tm_getRelatedDocuments. So this will list the top ranked documents related to the specific document. Again, what do we mean by document? Well, if I go to product reviews, this is what we call a document. So this SQL statement is essentially going to return all the top ranked documents based on this document. Now, the document I'm going to use as an input parameter is where the ID equals 14. So quite simply here, I'm trying to identify all the documents which are similar to this document. Now, how do we determine whether it's similar? Well, what we mean is that it's similar in terms of having the similar number of words and the similar frequency of words. So let's execute it. So again, if I go back, the input parameter is document number 14. We're specifying that from the index we want to search the content column from that text mining product reviews column. So here we're looking at this column. And essentially here we're just saying return the top 16 results. What we're outputting is the ID, the content, the total number of terms, and the count of those terms, and the total score. So I'll execute, and here we can see the results. So just a few words of note. Obviously the result at the top, because it's been ranked by score, and because we specified where ID equals 14, of course this document is going to exactly match the input parameter. So that's why the score equals 1. And then it lists, of course, the total term count. But then you've got other words, other documents, which contain, again, the similar number of words in a similar frequency. So you can see if I look at here, it looks like it's some form of restaurant service. If I go back here, this was where they were talking about being hungry, having a delicious meal, great staff. And as we go down, even though we find the total term count might be getting higher here, you can see here the total term count is 241. Because the document isn't really similar to the main document ID number 14, the score is getting lower and lower. So as you can imagine, essentially this document here has more in common with this document than this document. So again, to look at the syntax, because the syntax is kind of the same when you're using these functions. So the first line is basically selecting the various columns from the function. The function obviously is called tmGetRelatedDocuments. Then we're specifying which document from our list of documents, and in this example we're specifying ID number 14. We're searching the content column from the product reviews table, that's this column here, of course. And then we're returning the top 16 based on ID and content. That's how it basically works. So let's look at another example. So I'm going to go back to my SQL console. So this is a different example which does some statistical analysis. And we're going to look at this more in depth in further videos, but just to show you, it does very similar. We're selecting all the columns. We're using the same function tmGetRelatedDocuments for that same document ID 14. We're looking at the same column in the same product reviews table, but we're returning different statistical analysis. So we've got principal components, clustering, and correlation when the score is above a certain number. So what I want to show here is that this is an example of a query that gets the principal components, it shows hierarchical clustering, and a correlation matrix. I don't really want to go into this, but the key thing what I want to show here, because this is hardcore statistics, is that we're combining text mining analysis in a select statement. So here you can see, for example, this is actually using the text analysis function, but at the end I'm appending, and I'm filtering based on a specific score. So this query, for example, can be used in an advanced application that lets you navigate and discover various documents. So again, if I just execute this, and again we're going to look at this content in another video, but again we're outputting the ID, the actual content, the rank, and the various list of correlations, factors, and rotated factors, as well as cluster levels and other hardcore statistical outputs as well. Again, the key thing I want to show here is that we're combining statistical analysis with an SQL statement. So we're combining text mining statistics in an SQL statement, which is easy for developers to use. So let's look at another function. We've looked at another way of analyzing data using statistics, but let's look at another function. So I'll go back to my SQL statement, and I'll replace this with another SQL statement using a different function. So here I'm selecting 7 columns, but I'm using a different function called getRelatedItems. You can imagine what it does. The input is a term, so my term is the word restaurant, and we're searching that content column in the product reviews table, and we're returning the top 16, we're ranking this by the top 16. So basically the input is a specific term, and the output is the significant terms in the document compared to my collection. So let's see how that works. So I'll execute. So we're using the word restaurant. And basically what we've done here is, again, we're looking for similar terms. We're not doing text analysis here, we're looking for similar terms. So here you can see, well, obviously we've got the document frequency 2, we've got a score, because when you've got things like restaurant and deal, it might be related to having a specific deal at a restaurant. But then if you look at some of the other words, we've got things like party, oysters, which you might eat at a restaurant, horrible service, happy hour. Again, the further you go down, the lower the score, although you can see that these terms all have the same score. So if I go back to the SQL statement and I change this, for example, to food, we're now looking for related items to do with the word or term food. And there you've got a list of related terms. So of course, food, the word food matches exactly, but then you've got things like menu, catfish, meal, table, so on and so forth. So again, to summarize, the input is a term, it will output a list of terms, and it's ranked by related terms based on co-occurrence. So while we did this for terms, we can also do this for documents. So again, what I'll do is I'll replace the existing SQL with another select statement. So instead of searching for the term to get the relevant terms, the input will be the document ID, but we're going to output the list of relevant terms. So it's more or less exactly what we've got in the previous query, again, apart from that the input is a document. If I execute that, you can see what's happening. So based on document number 14, the input is document, it's going to output some terms, and it's going to return the top ranked relevant terms or key phrases that describe that specific document. So let's have a look at one more example which is kind of related. I'm going to go back to my SQL and I'll paste in a new select statement. So this one we're going to use a function called getSuggested_terms. So this query gives us suggestions for a search field when a user starts typing. It essentially does a prefix search on the content in the text mining index, and it's ordered by the TF/IDF weighting. Again, we looked at that briefly in the chalkboard video, but to just explain how that works, imagine you're like on a Google page. If you type the word, the letter A, it's going to come up with all these terms in all the relevant documents. Now, of course, if I type AB, so the next letter is a B, and I run the same search again, you're going to get any other terms. So obviously there's no terms here. Let's type an AC. You can see these are all the terms which start with the characters AC. So this is really to be used by specific applications. There's some other examples which we're going to cover to do with categorization, and we're going to look at those categorization text mining functions in the next video. So I hope you enjoyed that short video. I'm trying to keep these videos as short as possible. What we looked at was some of the basic term document functions, which are a subset of text mining functions, which are new in SAP HANA SPS 10.